This lesson is on geometric transformations using matrices for finite math. So far in this chapter, we have talked about using matrices to store information. We've talked about how to add and subtract matrices, how to multiply by a scalar factor, and how to multiply some matrices together. As far as that goes, today we're going to be doing all of those things. So one thing that we can do with a matrix is actually store a geometric figure that is housed on a coordinate plane. For example, I have this kite over here with vertices A, B, C, and D. And the way we would represent this figure in a matrix is to have our x coordinate and our y coordinate stored as a row, and each particular vertex would be stored as a column. So you learned in Algebra 2 that a transformation is some sort of change that's made to the original figure. Our original figure is called the pre-image, and our transform figure is called the image. Once we have this data stored in a matrix, it frees us up from having to actually look at a coordinate plane anymore. So one of the types of transformations that you learned about in Algebra 2 is something called a translation. A translation is basically when you slide or shift the figure without changing its size or the shape. We would use a translation using matrix addition, and we can translate the vertices. So for example, given a triangle ABC, where A is the coordinate -4, 1, B is -2, 5, and C is 0, 2, translate the pre-image 5 units right and 3 units down, and then sketch the image. Okay. Now you could do this on a coordinate plane. So I've got -4, 1, -2, 5, and 0, 2. There is my original image. And you could do this by hand. I want each to go 5 units right and 3 units down. So I could start here. I could go 5 units right, 1, 2, 3, 4, 5, and 3 units down, 1, 2, 3. That would put me there. And 5 units right, 1, 2, 3, 4, 5, and 3 units down, 1, 2, 3. And 5 units right, 1, 2, 3, 4, 5, and 3 units down. And again, I've got this translation. Okay, so over here, this is my pre-image. And over here, I have the actual image, or after the translation has occurred. But the idea is we don't really want to have to use a coordinate plane to do this, and we don't need to. We can actually take our matrix. Remember, we'll have an x and a y, and we can make each point in our matrix a column. So vertex A would be -4 and 1. Vertex B would be -2 and 5. And vertex C is 0, 2. And I can add to that. And remember, if you add, you have to have a matrix of the same size. So I want something that has 2 rows and 3 columns. I could actually put this change in there, 5 units right. So I would think, what do 5 units right do? Well, that would take my x value, and I would add 5 to each of those values. And 3 units down, I would want to subtract 3. That gives me my translation matrix, and this shows scooting it 5 units right and 3 units down. And I can go ahead and add. Remember, we add corresponding parts together. -4 and 5 make 1. -2 and 5 is 3. 0 and 5 is 5. 1 and -3 is -2. 5 and -3 is +2. And 2 and -3 is -1. And what I get are a new set of coordinates, A, B, and C. And a lot of times I'll write A prime, B prime, and C prime to show that they've been changed from the original. And this tells me that my new coordinates, the new point for A is now 1, -2. And the new point for B is now 3, 2. The new point for C is 5, -1. And if I check over here, 1, -2, there it is. 3, 2, there it is. And 5, -1. There it is. So the idea is that we can use a matrix, and we free ourselves up from this grid to where we don't even have to use the grid anymore. We can just represent our vertices as a matrix, create the translation matrix, and get our answer. All right, so here's another one. It says, given the quadrilateral ABC, oh, that should be ABCD. How about that typo? Quadrilateral should have 4 vertices, where A is 3, 0, B is 5, 2, C is 5, 4, and D is 2, 4. Translate the pre-image, 6 units left, and 2 units up. Now, if you had a piece of graph paper, you could graph these and physically do this change. That would be fine. But I don't need to do that. I can create a matrix to house my points. We should have an X and a Y. We should have A is 3, 0. B is 5, 2. C is 5, 4. And D is 2, 4. And if I'm going to shift this, I'm going to make some addition and subtraction. It needs to be the same size, so we're talking about 2 rows and 4 columns. And we would try to take care of this. 6 units left, so that's an X change left, and I want to subtract to make something go left, so minus 6, minus 6, minus 6, and minus 6. So in other words, if I'm at 3 and I scoot 6 units left, I'm anticipating ending up at negative 3. 2 units up, well, I would want to add 2 to make this go up. Okay. This is going to give me a new 2 by 4 matrix. 3 and negative 6 give me negative 3. End up with a negative 1, negative 1, and negative 4. Here we're going to add 2. That'll give me 2, and 4, and 6, and 6. This is my new A, my new B, my new C, and my new D. So basically, I can say that my new image has the following vertices. A is negative 3, 2. B is negative 1, 4. C is negative 1, 6. And D is negative 4, 6. And that's my new image. So a translation is really just adding. And again, I don't even need a graph to do this with. I don't need a coordinate plane. I can just use the matrix itself and use the idea of matrix addition that we did on the very first day of class. All right, something else that we can do with a matrix, a type of transformation, is called a dilation. Now, when you're dealing with a graph, a lot of times we use the word stretch or compress with a function. This is similar, except for a dilation is more like you walk up to a photocopier and you say, I would like to increase this by 110%, or I would like to decrease this to 75% the original time. So a dilation is a transformation that changes the size of the pre-image. Basically what you've got is a dilation factor that you're going to multiply by the pre-image. Or another idea is here is we're talking about a scalar. Okay, so this is a scalar factor like we dealt with in section 2. So on day 2 we did scalar factors. That's really all that dilation is. Okay, so given a given a triangle ABC where A is negative 2, 0, B is 0, 4, and C is 2, 1, increase the triangle by a factor of 2. That's basically saying I want to double this figure. Okay, so I'm going to start off with my matrix that represents my vertices here. So A is negative 2, 0, B is 0, 4, and C is 2, 1. Okay. As far as the dilation factor, it says a factor of 2, so I'm going to put a scale factor out front. And remember, the scale factor is basically a distributive property. I'm going to double everything in here. Negative 4, 0, 4, 0, 8, and 2. Okay. This tells me that my new coordinates, A, are negative 4, 0. B is now 0, 8, and C is 4, 2. And if you wanted to, you could go ahead and put those on the grid. Negative 4, 0, 0, 8. Oh, that's way up here. 4, 2. And we get our answer. Okay. Given the quadrilateral, so there should be 4 vertices, A is 4, 3, B is 0, 5, C is negative 10, 14, and D is 1, 1.5. increase the figure by 150%. Okay. Now, 150%, we need to turn this into an actual number, not a percentage. So 150%, you may recall, is 1.5 or 1.50. So that is going to be my scalar factor to state the vertices of the new image. So all I need to do is take that scalar factor and go through and multiply. Okay. Now, if you're doing these in your head, remember 150% basically adds on half of the original value. So half of 4 is 2. So 4 times 1.5 is going to give us 6, and so on. You could think half of 10 is 5. So if I multiply by 1.5, I'm going to get negative 15. And here I get 1.5. 3, if you think half of 3 is 1.5, we're going to add that back on. That's 4.5. You could also just go through and multiply, I suppose, by 1.5 on all of these. What would the fun in that be, though? 7.5, 21, and then 1.5 times 1.5 gives me 2.25. So these are my new coordinates. I basically just increased by a scalar factor of 150%. My new points, my new A is 6, 4.5. Our new B is 0, 7.5. Our new C is negative 15, 21. And D is 1.5, 2.25. There we go. So again, I don't need a coordinate plane to do this with. I can just deal with this right on the matrix itself. Okay, so far we have added. A translation is an addition or a subtraction. That's adding and subtracting matrices, just like day one. Nice little review of day one. We talked about dilation being a scalar factor, just like day two. And now we're going to talk about reflections and rotations. Now, reflection and rotation, they use multipliers. So a reflection or a flip is a transformation that creates symmetry on the coordinate plane. It's when you take your figure and you flip it over some line. A reflection maps a point or a figure in the coordinate plane to its mirror image using a specific line as its line of reflection. Or in other words, it depends on where you put your mirror at to see where the reflection is going to end up. Usually we're going to use one of 4. Either across the x-axis, that would be the horizontal axis, across the y-axis, that's vertical, across y equals x, that would be a slope of 1 going through the origin, and across y equals negative x, that would be a slope of negative 1 going through the origin. These flips and reflections are on your formula sheet. So you may want to grab that so you don't have to keep flipping back to this page in your notes. Also, as a note, you do not have to have these memorized for the test or quiz, but you do need to know how to use them. Okay, so we are going to multiply to get our reflection. It says the reflection matrix. Notice that the reflection matrix is always a 2 by 2 matrix when we're dealing with something in the coordinate plane. So our pre-image matrix, that one is 2 by something. Okay, because different numbers of points would give you different numbers of columns. So it's important that you put the reflection matrix first so that your inside dimensions will match. Remember, you can only multiply if the inside dimensions match here. Okay, so given the quadrilateral, A is 2, 1, B is 8, 1, C is 8, 4, and D is 5, 5. Find the coordinates of the image after the reflection across the y-axis. All right, so I'm going to go up here and find the one that says across the y-axis. I'm going to put it out in front. That's negative 1, 0, and 0, 1. All right. Now remember when we multiplied yesterday, we said we're going to do rows times columns. The great thing about these rows is there's really only one number and there's a bunch of zeros. So when we go to do rows times columns, we can almost do this in our head without having to do a whole lot of extra addition. Okay, so I'm going to take row 1 times column 1. Row 1 times column 1 would be negative 1 times 2 plus 0 times 1, and that'll give me a negative 2. row 1 times column 2 would give me negative 1 times 8, that's negative 8, plus 0 times 1, that's negative 8. Row 1 times column 3 is negative 1 times 8, that's negative 8, times 0 plus 4. So I just end up with negative 8. Row 1 times column 4 is negative 1 times 5, that's negative 5, plus 0 times 5. So I end up with just negative 5. Okay. I'm going to go ahead and do row 2 times column 1. Row 2 times column 1 would be 0 times 2, that's 0, plus 1 times 1, 1. Row 2 times column 2, 0 times 8 is 0, plus 1 times 1 is 1. Row 2, 0 times 8 is 0, plus 1 times 4 is 4. 0 times 5 is 0, plus 1 times 5 is 5. If you notice what happened when we reflected across the y-axis, all the x-coordinates flipped signs and the y-coordinates stayed the same. So my new points, A is now negative 2, 1. B is negative 8, 1. C is negative 8, 4. And D is negative 5, 5. And you could put primes on those if you wanted to show that they're changed. Okay. The next one says we're going to flip the same image across y equals x. All right, so here's y equals x. That's 0, 1, 1, 0. Remember that our original pre-image was 2, 1, 8, 1, 8, 4, and 5, 5. All right, so I'm going to do rows times columns. Okay. So row 1 times column 1 gives me 0 times 2 and 1 times 1, that's 1. Row 1 times column 2, 0 times 8 and 1 times 1, that's just going to be 1. Row 1 times column 3, 0 times 8 is 0, 1 times 4 is 4. And then row 1 times column 4, 0 times 5 is 0, 1 times 5 is 5. I'm going to go through and do row 2 times each of the columns. Row 2 would be 1 times 2 and 0 times 1, that's just 2. 1 times 8 is 8, 0 times 1 is 0, so I just get 8. 1 times 8 is 8, 0 times 4 is 0. 1 times 5 is 5, 0 times 5 is 0, so I just end up with that 5. You can see that after the reflection across y equals x, we have new points of 1, 2. We have a new point of 1, 8. We have a new point of 4, 8. And we have a new point of 5, 5. So essentially what happened is all the y's became x's and all the x's became y's. And again, multiplying by these are usually pretty easy to do because you usually have a 0, so it knocks out one of the decimal places, it knocks out one of the values, and you just have a multiplier by 1 or negative 1 on your other number. A rotation works basically the same way. We are usually rotating around a fixed point, and we're considering a rotation either 90 degrees, okay, 180 degrees would take you across, 270 takes you 3/4 of the way around, and 360 is one complete rotation. Okay. All right, so again, we're going to take our rotation matrix. We're always going to put that first because it's 2 by 2. We can line that up next to our pre-image, which is 2 by something, we don't know. That'll make our inside dimensions match. Okay, so the next one says, rotate the triangle with the vertices 1, 1, 5, 2, and negative 2, 3 by the stated amount, and give the vertices of the new image. All right, so I'm going to rotate 90 degrees. And again, those are on your formula sheet, so you have those you can use for your homework. You don't have to flip back and forth through your notes. You don't have to memorize them for the test. And we're going to do rows times columns. So I'm going to start off with my first row times my first column. Row 1, I get 0 times 1, that's 0, and negative 1 times 1 is negative 1. Row 1 times column 2, 0 times 5 is 0, negative 1 times 2 is negative 2. Row 1 times column 3, 0 times negative 2 is 0, negative 1 times 2 would be negative 3. Okay. I can go ahead and do row 2 times column 1. That would give me 1 times 1 and 0 times 1. That's just 1. Row 2 times column 2. That's 1 times 5 and 0 times 2. And then 1 times negative 2 and 0 times 3. So my new image has vertices at negative 1, 1 and negative 2, 5 and negative 3, negative 2. All right. Next one says rotate the same triangle by 180 degrees. So I'm going to use this matrix this time, negative 1, 0, 0, and negative 1. Again, I have my pre-image. Pre-image is 1, 1, 5, 2, and negative 2, 3. All right, I'm going to do rows times columns. So negative 1 times 1 is negative 1, 0 times 1 is 0. Rows times columns. Negative 1 times 5 is negative 5. 0 times 2 is 0. Rows times columns. Negative 1 times negative 2 is a positive 2. 0 times 3 is 0. Then my second row, 0 times 1 is 0. Negative 1 times 1 is negative 1. 0 times 5 is 0. Negative 1 times 2 is negative 2. 0 times negative 2 is 0. Negative 1 times 3 is negative 3. And then I have my answer. A is negative 1, negative 1. B is now negative 5, negative 2. And C is 2, negative 3. So again, we're just multiplying just like yesterday by a rotation matrix. And you don't have to memorize that rotation matrix. The only thing you do need to remember is that it needs to be in the front of your matrix. If it's not in the front of your matrix, you're not going to be able to multiply it because the number of rows will not work. The only way this could possibly work is if you had a square. You could multiply it in the other direction. All right. So I have another example, and it says a triangle has vertices of 1, 1, 5, 2, and negative 2, 3. All right, so that's the same as the last problem. This is my pre-image. And it says, first, the triangle is rotated 90 degrees. First, the triangle is rotated 90 degrees. Okay, so let's go ahead and do that 90-degree rotation. Again, that's 0, negative 1, 1, and 0. You can get that from the box or from your formula sheet. I'm going to take my pre-image here, write it next to there, and show that multiplication. All right, so when I go to multiply rows times columns, you can see this is the one that we did previously up in the previous example. So I'm going to end up with negative 1 and negative 2 and negative 3 and then 1 and 5 and negative 2. So that's already been done. It says next, the triangle is reflected across the y-axis. All right, so I'm going to go flip back real quick. Reflected across the y-axis has a reflection matrix of negative 1, 0, 0, and 1. And this time I'm going to take the image that I just worked with. So negative 1, negative 2, negative 3, 1, 5, negative 2. Okay, and we're going to do rows times columns. Rows times columns. So I end up with negative 1 times negative 1 is 1, and then the 0 cancels out. Negative 1 times negative 2 is 2, and the 0 cancels out. Negative 1 times negative 3 is 3, and the 0 cancels out. In the bottom, 0 times negative 1 is 0, 1 times 1 is 1. 0 times negative 2 is 0, 1 times 5 is 5. And 0 times negative 3 is 0, 1 times negative 2 is negative 2. Okay. Next, it says, finally, the triangle is translated right 3 and down 4. All right, so right 3 and down 4. If I take my triangle 1, 2, 3, 1, 5, negative 2 here, and I want it to go right 3, that means I want to increase the x value by 3. Down 4 means I want to decrease the y value by 4. And if I'm going to add, that means it needs to be the same size. Okay, that's going to give me 4 and 5 and 6, negative 3, 1, and negative 6. It says, what are the final coordinates of this image? Okay, well, Our A prime is now 4, negative 3. Our B prime is now 5, 1. And C prime is 6, negative 6. Okay. So your job today, as we are preparing for tomorrow, which is a quiz, if you haven't done so already, you need to finish your day 3 homework. That's all those multiplication problems from the textbook. Okay. You need to do the day 4 homework, which is the back of the worksheet that you received. Okay. There are, I think, 7 questions on that. Okay, which is going to be all over translations. You need to get that completed. Okay. Oops. We don't need Skype for Business. Let's try again. And then you need to do your Chapter 2 quiz study guide, which you received yesterday. If you don't have those, you can pick up an extra in the windowsill. Ask somebody who was here to help you find it. This one is not for grade. The answers are posted to the Chapter 2 study guide on the classroom website in the Schoology folder. Okay, so you should be able to go on there and check your answers. Tomorrow, next time I see you, Thursday, we do have a quiz, and these first 2 homework assignments are due. Okay. If you have any questions at all as you're working on 1, 2, 3, and studying for that quiz, you can email me. You can message me through Schoology. Or you can come in before school tomorrow. I'll be here at 7:15 in this classroom. Have a wonderful day and be ready for that quiz next time.